All right, so in this video, I'm going through the study for Unit 2. These are the last couple of pages of your notes packets. This is very similar to your test, so this is the best content to be studying if you want to prepare for your test. This first one, we're just identifying the types of functions, so they're kind of just the parent functions. We're starting with a name, family of functions, the equation of the simplest version, and then a graph of it. So the simplest rational function we've learned is just 1 over x, and that's the one where the graph looks something like this. It goes out that way, goes back that way, goes off to infinity like this. It asymptotes to x equals 0 and to y equals 0. Right here we have y equal to a, where a is some number. Keep in mind, this is not y equals x. This is not just a generic line. This is a horizontal line. At y equals a. All right, and then the V shape always tells us that it is absolute value. And our generic parent function equation is y is equal to the absolute value of x. All right, and then down here we have some domain and range questions. And so this is for a continuous function, and we want to write set and interval notation. So our set notation here, well, the x values start at 4, so we can say all values where x is greater than or equal to -4, right? Because they start at 4, and they go on forever in the x direction. We can represent that in interval notation with a bracket, because -4 is included, comma, parenthesis, infinity with a, or comma, infinity with a parenthesis. Now for the range, that's where we're talking going up and down. So it is in set notation, it is y, where y is greater than or equal to 0. And then for the interval, that's bracket 0, comma, infinity, parenthesis. Okay, now down here, we can tell that this is a discrete function. And we know it's discrete because it's only defined at these points, right? It doesn't say that it's defined between those points. So we're going to assume that those are the only points for which this function is defined, meaning that the domain is going to be the set of the x values. So it's 2, 3, 5, 7, and 9, right? Those are all of the x values where the function is defined. And the range is going to be the set of y values where the function is defined. So it's going to be 1, comma, 3, comma, 4, comma, 5, comma, 6. And notice how I'm writing them from least to greatest. That's what we want to do with domain and range. All right, and then on page 20, we have we have the function y equals f of x graphed, and we're applying some transformations to the function y equals f of x to create a new function. And so here we are doing two things. One, we're reflecting it across the across the x-axis, right? We're making it negative, so it's a vertical reflection, and then we're sliding it up 1. So to reflect it across the x-axis, we're just going to make all of the points that used to be positive now negative, and all of the points that used to be negative now positive. So it's going to look like this. Then I'm going to draw the new function g of x in red, and g of x is going to be started from our reflected version of f of x, and then we're just going to translate everything up 1. So our new function g of x is going to look something like that. So this is g of x. All right. And then here we have f of x plus 2, and we're adding 2 in parentheses. So we know that that means we're going to shift it 2 to the left. So all of the points here are going to get shifted 2 to the left, meaning that the final result here is going to look something like that, g of x. Okay. So now let's go down here where we have some arithmetic with different functions. So remember f plus g of x, that's like saying f of x plus g of x. So that would be x cubed plus 1 plus 1/2 x squared. And all you can really do there is you can write it in more standard notation where we have decreasing powers. So I just write x cubed plus 1/2 x squared plus 1. And now here we have f minus g of 6, which we can think of as f of 6 minus g of 6. And so f of 6 is 6 cubed plus 1, so it's 217. And then g of 6, that's minus g of 6, which is 1/2 6 squared, which is 18, meaning that the difference is 199. All right, and then h of 1 is 1 over 1 plus 1. That's 1 over 2. F times g of x, well, for that we have to take f of x, multiply it by g of x. So f of x is x cubed plus 1. G of x is 1/2 x squared. When we multiply them, we need to distribute like that. So you're going to get 1/2 x to the 5th plus 1/2 x squared. All right. And now we have h times g of 1. So h times g of 1. Well, we can either think about that as let's find h times g of x. And also notice here how this dot here means multiplication. Right down here we have open circles, and that means composition of functions. We'll do that next. Here we're multiplying. So we can either think about that as, so we can either find h times g of x, which is h of x times g of x, which is going to be 1/2 x cubed over x plus 1, right? Just taking h, h of x, multiplying it by g of x. And then if we want h times g of 1, we want to plug 1 into that. And we're going to get 1/2 over 2, which is the same as saying 1 over 4. I mean, you could also do that separately. So you could also find h of 1, and h of 1 is going to be 1 over 2. G of 1, that's also going to be 1 over 2, and then multiply those results. 1 over 2 times 1 over 2 is still 1 over 4. So you can either find the multiplied function, h times g of x, and then plug in 1, or you can plug in 1 to h of x and g of x, and then find the products. All right, and so now we're looking for g of x. So here we have to take g of x, which is 1/2 x squared. And then where we see x, we want to plug in g of x. So that's going to become 1/2 parenthesis 1/2 x squared squared. That's going to be 1/2, and then when you square what's on the inside, you're going to get 1 over 4 x to the 4th, meaning that our final answer is 1 over 8 times x to the 4th. All right, so now we get into the composition of functions where we have two different functions. So f of g of x. So that would be, so f of x is, sorry, f of x is x cubed plus 1. So we want to take that g of x and plug it in for the x in f of x. So that means f of g of x is going to be equal to 1/2 x squared cubed plus 1. So the result is going to be 1 over 8 x to the 6th plus 1. All right, and then we have h of f of x. So now our h of x is there, f of x is there. So that's going to look like x cubed plus 1 over x cubed plus 1 plus 1, right? 1 plus 1 from f of x itself, and then 1 plus 1 that's inside of h of x, meaning that this can simplify to x cubed plus 1 times x cubed plus 2. And we can't simplify it any further than that. That's as far as it goes here. All right. And we have f of g of 3. So I'm going to do this in 2 steps. I'm going to find g of 3 first. And g of 3 is 1/2 times 3 cubed. So that is 9 over 1/2. Nope, sorry. 1/2 times 3 squared, which is going to be 9 over 2. And I want to plug 9 over 2 into f of x. So f of 9 over 2 is going to be 9 over 2 cubed plus 1. So that's going to be 729 over 8 plus 1, which we can turn into a decimal if we go over to our graphing calculator. 9 over 2 cubed plus 1, we get 92.125. Let me just make sure. All right. So on this page, we need to find the equations based on the graph. So we know that this is going to be like our parent function, y equals x squared. And then what are we doing to it? Well, we are shifting it 2 units to the left. So we can do x plus 2 squared in parentheses. We're moving it up 1, and then we're flipping it over the x-axis. All right, so you think about that as we start with our normal parabola. If we flip it, we're there. If we move it 2 to the left, we're there. If we move it up 1, we're there. And if we reflect all of those in the equation, this is what we end up with. And then is this a function? Yes, this is a function. Passes the vertical line test. All right, and the equation for the circle, we can see that the radius or the center of the circle is at 2, -3, meaning that our equation here is x minus 2 squared plus y plus 3 squared. And that's equal to r squared. And here, what is our radius? Our radius is 1. So it's 1 squared or just 1. And this is not a function, right? This is just a relation. All right, so we might immediately notice this as an absolute value. So you get y equals x. But we might also notice that it's vertically stretched. So if you think about a regular y equals x, when you plug in 1, you should get 1. Here, when we plug in 1, we get 3, meaning that we know that the equation for this is y is equal to 3 times the absolute value of x, right? Because instead of going over 1 up 1, we're going over 1 up 3. And is this a function? Yes, it is. Okay. I want to read values from the graph. So what is f of 0? Well, that's saying when x is 0, so when we're on the y-axis, what is the value of my function? So f of 0 is -6. This is saying when we're at 6, what's the value of the function? Well, that's also -6. For what values of x does f of x equal 2? Well, that means we take our horizontal line. This is where f of x equals 2. And we see that we cross at 2 points, 2 and 4. So for what values of x does f of x equal 2? For x equals 2 and x equals 4. Okay, so now we have this problem over here where we have this function and we need to sketch at least 3 points. So let's figure out the values. I'm just going to throw in -2, 0, 1, and 2 here. Let's see if that's helpful. So when we plug in -2, we have -2 to the fourth plus 4 times -2. -2 to the fourth is positive 16, made negative by the negative outside, minus 8, so it's -24. For -1, we will have -1 to the fourth plus 4 times -1. That becomes positive 1 made negative, so -1 minus 4, so -5. 0 is just going to be 0. 1 is going to be -1 to the fourth plus 4, so 1 is going to be positive 3. And then 2 is going to be -16 plus 8, so -8. So these are the 3 points that are going to help us graph it. So we can go -1, -5, 0, 0, and then 1, comma 3. And then 2, so we know after this, it goes way down to infinity, and then after this, it goes way down to infinity. So we know that the graph of the function is going to look something along the lines of that. And we can verify that in the calculator. If we go here, we can go y is equal to -x to the fourth plus 4x. Change our window to be more rational than what I was using it to do before. We hit graph, we see that looks something like that. Yep, pretty similar. As long as you have the points there and the shape is in the general direction, then you will be good. All right, so now we need to add the function g of x shown to the function of f of x shown above. Use your graphing calculator to find all of the solutions to the equation f of x equals g of x. Round your answer to 2 decimal places. All right, so we want to add our second function here in y2, and that is the cube root of x plus 1. So use the cube root, we want to go math, and then down here, cube root x plus 1. And we graph it, we see that there are 2 intersections there. Hold on, x plus 2. Yep, I had the function wrong, so we just want to change that to be a 2. But still, when we graph it, in here it's kind of hard to see. Does it hit once? Does it hit twice? So let's change our window. Let's change it to be from 0 to 4, and then from 0 to 4, and then graph it. It's still hard to see if we hit it or not. So let's change our window again to be, let's go from 1 to 4, and then from 0 to 3. Okay. So let's go 0 to 2, and then let's go 2.5 to 3.5. All right, now we can kind of see, if we look really closely there, there's actually 2 intersections. So if we go second calc trace intersect, first curve, second curve guess intersection, we can see that one of the intersections is at 1, comma 3. So that occurs when x is equal to 1. And the other one that is just to the left of it, second calc intersect, just to the left of it, enter, 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 is when x is equal to 0.94. That intersection point is 0.94, comma 2.98. Okay, so now we're down to the review stuff. There may be a small review section on the test. So I want us to pay more attention and review the types of problems that we saw in Unit 1. So the first thing that we can do here is we can flip this to the bottom because it is negative, and we can also divide 5 and 10. So it means we'll have y to the 3 halves over 2, right? Because if we cancel out 5 on the numerator and the denominator, we're left with 2 in the denominator, times y to the 5th, times z to the 3rd, times z to the 9th. All right, now we can combine the z's by adding their exponents and combine the y's by subtracting their exponents. So that's going to be, if we take y to the 5th and turn y to the 5th into y to the 15, or y to the 10 over 2, well then when we subtract those, we're going to get 2y to the 7 halves in the denominator times z to the 12th. And that, so we'll just put a 1 on the top since there's nothing else on the numerator. And so now we want to change this to be in radical form. So we're going to go 1 over 2z to the 12th times the square root of y to the 7th. Then we can simplify that to 1 over 2z to the 12th y, let me write my variables in the right order, y cubed z to the 12th square root of y. And that would be my final answer. All right, now over here. So the first thing I'm going to do is I'm just going to evaluate my negative exponent here, and I'm just going to flip everything inside. So I'm just going to turn this into 162 a cubed b to the negative 3 c to the negative 4th over a to the negative 10th b to the 4th c to the negative 3rd, and all of that now to the positive 1/4. Right, so I just essentially did the negative 1 power and just flipped everything. Okay, now I'm going to flip everything else that is inside. So it's going to be 162 a to the 3rd times a to the 10th times c to the 3rd over b to the 4th times b to the 3rd times c to the 4th. Now all of that to the 1/4 power. Okay, now I'm going to simplify inside. I'm going to get 162 a to the 13th over b to the 7th c. All of that to the now positive 1/4. And now I can take everything inside to the 1/4 power. So it's going to be 162 to the 1/4, a to the 13 over 4 over b to the 7 over 4 times c to the 1/4. And now I can turn those all into radicals. So we can write this the 4th root of 162 times the 4th root of a to the 13th over the 4th root of b to the 7th times the 4th root of c, which I can simplify to be, remember 3 to the 4th is 81, and 81 times 2 is 162. So that means that the 4th root of 162 becomes 3 times the 4th root of 2 times a cubed 4th root a over b 4th root b cubed times 4th root of c, meaning that my final answer, after I've done kind of all of that simplification, I can write it 3a over b times the 4th root of 2a over b cubed c. That's my fully simplified answer. Okay. So if we go over here, this problem may look scary, but we can remember that we can use our radical properties to put it all under one radical. So 60 x to the 8th, y to the 6th, over 120 x to the 4th, y to the 5th. And now we can simplify what's inside there. So that would then become the square root of x to the 4th, y over 2, which I can then break out again into two separate radicals to be the square root of x to the 4th, y over the square root of 2, or x squared root y over root 2. And then I can rationalize by multiplying by root 2 over root 2, meaning that the final answer is x squared 2y over 2. Okay. Over here, I'm going to start by just simplifying this. Again, remembering that 2 to the 4th power is 16. So 32 is going to become 2 4th root 2. So we can put a 2 outside. X squared y times the 4th root of 2xy. And we're going to add that to x times the 4th root of 2xy. And so that's a fully acceptable answer here, right? We can't add these two because they are unlike terms, even though they have the same radical. This one has a y, whereas this one does not. So this is our final answer. If you wanted to, you could also write it 2x squared y plus x times the 4th root of 2xy. But that doesn't really, right, that's not really any easier to work with. So I would recommend just leaving it like this. Right, and then when we look over here, so once again, we can simplify this to be negative 45 over 135. And actually, I'm going to go even further. I'm going to say that's the square root of negative 1 times the square root of 45 over 135, which is the same as saying I times the square root of 1 over 3. The same as saying I over root 3 is the same as saying I root 3 over 3. So remember, we can put it all inside one radical, split out the I, simplify what's inside, right? 45 goes into 35 3 times, and then just rationalize the denominator there. Okay, here we need to rationalize by multiplying by the conjugate. So 4 plus root 5x, 4 plus root 5x. All right. And so in the numerator, we're going to have 4 root x plus 5, or plus, so plus the square root of 5x squared, minus 8 minus 2 root 5x over 16, plus 4 root 5x minus 4 root 5x, and then minus just 5x, right? Because that would be root 5x times root 5x, which would be root 25x squared, or just 5x. So a couple things we can do here. One, we can cancel these two out. Okay, that's why we multiplied by the conjugate. And then the other thing we can do is we can simplify this x squared up here. So we can turn this into 4 root x plus x root 5 minus 8 minus 2 root 5x over 16 minus 5x. And that would be as far as we can go.